Aloha, Richard Halverson here. This is ITS128, and let me share my screen. Get started here. 3. Let's see. ITS128, and the syllabus today is the 17th of September. So if we go down to the 17th of September, that's in here. Okay, we're doing chapter 4, branching. Okay, so let's see. Great, let's open up chapter 4, see what that looks like first. Chapter 4, branching. Ooh, a lot of labs. Oh, great. Okay, so let's let me see where we left off last time. It's been a while. So we haven't gotten to chapter 4 yet. Three goes up to 11. Okay. This is 17th. Okay, we're still in. All right, so I guess we're gonna have to go back to chapter 3. Let's see how far we got. Sorry, I should have done this before. 3.4 sets, I see. So the further we got. Yes, I was very busy, but I'm done. Okay, so let's go back to chapter 4 and chapter 3, and to make this meaningful, I'll do a couple lab exercises. Okay, I'll be sure to get those in. In fact, 3.4, we got up to 3.4. Let's go see what 3.4 is. Sets, bait, tuples. No, none of these really talks about set space. Okay, so let's go on to chapter 5 or section 5, dictionary basics. Okay, so there's another case. So we're talking about data types here, and these are the basic, the elementary, the most basic kinds of data structures or objects that can store stuff. And so we can store strings. Of course, that's useful for sentences or words or anything, or text, or that's very important. There's numbers too. I don't see numbers. So, but anyway, there's numbers, which are there's the 3 different. There's integers. There's numbers that have decimal points and numbers that don't have decimal points, basically. But then Python offers at the base level these more sophisticated structures that can grow in various sizes and everything, that turn out to be very useful for all the stuff that you have to be able to do, programs have to be able to do in all of the various applications and industries that exist. And so they've kind of been broken down, and other languages have most of these features, but none of them really have them all as completely and they're all very consistent. So they make they're consistent among one another. And so it's. So that's what we're learning here. Okay, so there was lists, and lists can be just as a string it is like an ordered list of characters. A list is like an ordered list of things, and those things can be numbers or character or any other kind of data type. They can even be lists. So in your list, you can have like the first one can be like an integer, the second one is a string of like your name, the third one can be a list of something, and so the fourth one is a set. And so That's lists. And then we talked about so lists have an order, and they're in an order, and they are it's mutable, which means that if you pass a list on to some other to a method, that method can mess with the list, and when that method is done messing with the list, and you go on to look at the list, it's going to be changed. Okay, whereas if it's immutable, it won't be changed. If it's immutable, when you pass the data item onto a method or a function or something to use it, only a copy of it is passed on it, so that subroutine can go ahead and mess with it, and it's not messing with the original. So these are differences in the different types of data structures here that can hold practically an unlimited number of things. Okay, so tuples are it's behaves similar to a list in that it is mutable, in that you can change it. But once it's it behaves similar to a list, but it's not mutable. In other words, it can't be changed. A list can be changed. So once a tuple is created, you can't change it. Okay. All that means is you pass a tuple on to somebody else, and that somebody else wants to make changes to the tuple. You pass that somebody else a copy of your tuple, and then that somebody else can mess with it all at once and pass back its copy, and you get the copy back, and it's different than the original, and so it would be used in that way. And tuples are represented differently. They're represented with the parentheses instead of square brackets. You'll notice lists are square brackets. Anyway, so okay, and sets are not ordered. Sets are like tuples, but they don't have an order to them. So like 1, 2, 3 is the same as 3, 2, 1, and also it's not going to have any duplicates either. So and they're represented using curly braces instead of parentheses. So here, what this does is this kind of converts a list into a set. Basically, here you're specifying a list inside that looks just like a list, right? It's got square brackets, commas. But there's a set function which will turn it into a set. Another way of defining a set is just using the curly braces right from the beginning, and just put them in there. So anyway, see, they both print the same kind of. When you print out the data structure just like that, it's going to come out like this. Okay, so that's sets. Dictionaries, now this is new. Dictionaries, they look okay. They use curly braces like sets when you represent them. They don't have and it's like a list of elements. However, in a list, you identify the different elements by its index, by its order. So like this is 0, and this is 1, and this is 2. Okay, well, a dictionary is like an associative array, or you don't identify the different elements by an index. You can't. You identify the different elements by a key value. So each element in the dictionary has a key, and that's how you identify it. It's kind of like a database kind of. That's a key. That's how you identify this element, and then this is the value of the element that we are identifying. So and so you can see that you can represent things like this. Well, this is, what's Cristiano Ronaldo? Okay, what is Cristiano Ronaldo? Well, either you don't have Cristiano Ronaldo in your dictionary, or you do, and it has a value, and you would return 7. So you would, if you ask, what's what's Christian Ronald? And then it would return no, because there is no Christian Ronald. Oh, well, what's Cristiano Ronaldo? Oh, it does have a value, so it returns 7. Anyway, so that's what a dictionary is, and we're in, this is 128, so I should go over this pretty thoroughly. So these are always good. Here we're defining. And by the way, when you define a dictionary, you can do it with these curly braces, just like you do with sets. And it's able to tell that you're defining a dictionary instead of just a set. And when you print out a dictionary, it prints out looking like this, just like how you would define it. Okay, so here's a run the program below, which displays the caffeine content in milligrams for different popular foods. Anyway, so here we have this dictionary where we have, this is the index and this is the value. This is the caffeine value. So this looks like that. Let's run it. And so here we're just printing out the content, printing out this whole thing. So what happens if we do print? I want to just print out Red Bull. Okay, so what happens when I do this? Oh, look, it just prints out Red Bull. So anyway, that's the dictionary. That's how dictionaries work. Okay, so use the braces to create a dictionary called Ages that maps names into their ages. Oh, you're supposed to say what this is. Okay, yeah, all right. So this is simply, let's see, Bob. Now, is there any rule about, okay, so here we're using single quotes. Sometimes when you're doing formats like this, it's important that you use the right kind of thing to enclose the key, the either double quotes or single quotes. In this case, I think it probably doesn't matter because you're just defining a string, and single quotes and double quotes are like the same in Python. They're not the same in other languages. In fact, they're not the same in most other languages, but in Python, they pretty much are. Bob is 27. And then we separate them by a comma, don't we? A comma. So we have Frank is 75. I'm not 75 yet. All right, check. Oh, oops. I shouldn't have that here. All right, okay, yep, made a mistake. All right, there we go. Okay, so when you access index entries, you do it just like I did up there in the example. You use square brackets now. You say the name of the dictionary, and then this is the key. This is the key, and you want to know what the value that corresponds to this key is. And so you have a dictionary like that, and you want to know what apples are, you just do that, see. Now we see that here we try to do lemons, but there is no lemons. And so this is an error. Now, what this traceback is in the stuff we're doing, it's sort of meaningless, but if we were when we start doing modules, or when we start doing methods, adding methods to our programs, and methods might have some methods and all that, and we're drilling down, the error can occur way down, be way down in some method that's called all over the place. So just to say that the error is in a line in a method, deep in a method, does not help that much because we don't know how it got there. So traceback usually traces back how it got to that point in that block of code. If there were, you know, the main program calling a method and then perhaps calling another method. So it shows the line. It would show the line number at each point where another method was called. Anyway, we'll see that. But it's important to start to learn what these error messages mean, because right now it's pretty simple. Okay, this is a key error. You tried to reference the prices of lemons, and we don't have anything for the prices of. We only have apples and oranges, so it couldn't find it. In fact, it's, you know, and so there must be something wrong. So it tells you now later on in chapter 10, we will be able to write our own code to handle these exceptions. It's called an exception, where if you're trying to reference a key in a dictionary that does not exist, print out a more meaningful message and not, you know, trace back most recent call last file stdin line 3. You know, that doesn't make sense to a lot of people, especially if you've written the program for some user and some users, you know, coding along. And when you write your code, you know, for somebody else, you want to make sure it takes care of all the possible wrong things or common, typical, and even atypical mistakes that a user might make in using your code. And it's not enough to say, well, you know, the user was stupid or that was a user error. No, there should be no user error, because your code should be able to track. And when the user types in something that's wrong, you know, you say, oh, that's not how you use the program. You use it, you know, you should type this, or don't type, when you're typing in a number, don't type commas. You know, don't type the $sign, you know, that kind of stuff. If your program is asking for an amount of money and the user types in a $sign, the user is probably going to get this, which means not something that looks like this, which would mean nothing to the user. And, you know, you want to have your program be more user-friendly than that. A dictionary entry is accessed by placing a key in curly braces. What? No, it's square braces, isn't it? Yeah. Oh, that's right. These are called, yeah, these are called brackets. Yeah, anyway. Yeah, these are called braces. It's a different thing than brackets. Anyway, a dictionary are ordered by position. No, I don't think that's true either. Oh, they are. Okay. They are in Python 3.7. The standard is for dictionaries to be maintained. To maintain their left to right insertion order. Though order, dictionary entries cannot be accessed by indexing. Okay, you know, that's kind of the important thing, because, you know, like if you have this dictionary and you want to start pulling stuff out of it, you can't just say, all right, give me the first one and it returns a key and a value, and give me the next one, it returns another key and a value. You can't do that. You have to know, well, to start it out, it's hard. You have to do something like first identify all the keys. You know, you can identify all the keys in a dictionary, and then once you know the keys, then you start accessing the keys one by one. But this would be for listing out a dictionary. You know, you might want to see it in the order that it was created. I mean, that's very, that would be a thing that you might want to do. So anyway, so I guess it does maintain an order, but I know it is ordered by position, but you can't get at it by its ordered position. It cannot be indexed. All right, so to add, there's special methods. Oh, that's right. You can just add this way. This is a good way. You can just say, okay, I want to make a new one called banana, and all you got to do is set a value to it, and it will automatically create that entry in your dictionary. You have to use the delete keyword to delete an entry. So you put delete or del space in the thing. Modifying, you just modify it like this. You just, you know, you put the dictionary with the key value in square brackets and that's on the left side of an assignment statement, and the right side is going to have you know, whatever it is you want to put in there. This deletes it. Now, just as an aside, this is how we declare an empty dictionary. So, you know, we declare an empty dictionary and then we start putting stuff in it. We can put stuff in it this way, just start assigning things. And if there already is a banana in there, it's going to overwrite it. You know, it's not going to tell you anything. It'll just do it. So you see this, and then this deletes it, and then you have nothing. Now, you know, curly braces is also used for sets, right? But this is not how you create an empty set. Okay, this will create an empty dictionary. To create an empty set, there's a special method to do that. I can't remember, set or something. Python. To create an empty set. Create an empty set, you use this. That creates an empty set. All right. Modifying them shows that you can modify them. Yeah, you can do that pretty easy. Okay, here's a challenge. What time is it? 12:52. We're still doing dictionaries. All right, dictionaries in types. All right, and then we're into the summary. Okay, so we have this dictionary that we've created. It's got 2 entries in it. Got one for Acura and one for Fiat. And I didn't know that Fiat was. Oh yeah. So Acura is made in. This will display that. So what is it? What are we supposed to do here? Write a statement to add the key Tesla with a value USA to car makers. It's funny because Teslas are made all over the place. Modify the car maker of Fiat to Italy. Sample output. Okay, so it should look like this. Right now it looks like this. Okay, so my solution goes here. Okay, so first thing I want to do is make I want to say car makers of Tesla is USA. I'm a minimalist and I don't put spaces in between my things. And then I got to change one of them, and it would be this one. Has to be changed to Italy. Okay. All right, does this work? Ah, yes, very good. Okay, types summary. Oh, summary. Okay, so here's a nice summary. There are numeric types. Int and float represent common types. Int, there can be a there's no decimal point, so it's whole numbers. With the float, with the type float, you have a decimal point. And then there's these sequence types. I don't see dictionary in here, but anyway. So we have strings, which are strings of characters. We have lists, which are, you know, lists of things, lists of various objects, lists of objects. Objects can be of any be of any type. And then tuples, which are all containers for collections of objects ordered by position in the sequence, where the first object has an index of 0 and subsequent elements have indices 1 to list and tuple are very similar, except for the list is mutable, and it means elements can be edited and removed. Conversely, a tuple is immutable. It means it cannot be mutated. And individual elements may not be edited or removed. All that means is when you want to edit a tuple, you're not really editing it, you're making a new one. But with a list, and you want to make some changes to it, you can actually just change the list itself, and it's just you're not making a copy of it or anything like that. That means you can pass the list on to somebody else, and they can make changes to it, or pass the address of the list on to somebody else, and they can go ahead and make changes to it, and that's it. And later on, when you go look at your list, it'll be different. Whereas you can't do that with immutable types. The only mapping type in Python is a dict type, a dictionary type. Like a sequence, it serves as like a sequence type. It serves as a container, except each element is independent and have no special ordering or relation to the other elements. So here's this. Okay, so these are the different types. The list. Okay, these are true false questions. The list is invalid. No, it's false that this is invalid because you can have that, I'm pretty sure. Int and float can always hold the exact same values. No. Yeah. A sorted collection of integers might best be contained in a list. I guess. All right. So this talks about choosing a container type. Okay, well, these are good exercises to go through. We often struggle with our needs, what to do. Okay, a student test scores that may later be adjusted, ordered from best to worst. Well, that would be a list. There's a lot of nice this doesn't talk about it, but there's a lot of nice methods that come along with when you create a list. There's these, there are these methods that come along with that creation, and one of them is just sort, and append and so on. So anyway, I think it's list. A single student's name, a name, and their final grade sounds like a dictionary to me. Oh. Oh, I see. Pairs of strings. So you have a sets. Okay, well that's interesting. Now I wouldn't have thought of even doing it that way. Well, I tell you the reason is I've never in all my programming in the past I've never programmed in a language that has sets. I mean, other than Python, but Python is relatively new for me. But I've never written a lot of large programs in Python, and it's those writing those large programs in a language where you get it to run, and that's where you learn about all these little idiosyncrasies and best ways of doing things. Okay, so I'm gonna have to pay attention to this, and when we do cover sets more, we're gonna do that in later on. Then I'm gonna think about that and probably emphasize that, because to me it would be a dictionary. I mean, even if it can, even if it does allow changes, I mean it doesn't mean you're gonna change them. So. All right. So anyway, so it's this answer. And okay. Next one is names and current grades for all students in the class. Well, now you got me scared. But is it sets again? Oh, there's sets is not listed here. Tuple. Well, I'm gonna say dictionary. All right. Dictionary can provide a map of names to grades, allowing for updates. Sure. Okay. All right. Finding errors in code. Okay. This is what are we supposed to do here? Click on the, oh, I see. Okay, so what this is good for is one of the things that you have to be good at it, or that you have to sort of feel like it's a welcome challenge or something, is being able to quickly identify syntax errors in your program. I mean, they should just, after a while, they should just stand out, you know. And so you should look at this and say, well, what's the error? What is this? Okay, so anyway, so we have 3 students, and we are creating a new dictionary called grades, and then we input the name, and then we input the grade, and then we want to append. Well, I think this is wrong. Oh, a list. Oh, append is this. No, this is wrong. Dictionary does not use append function. Okay, so do it. Okay, all right. The next one is workers. These are 2 workers. Remove Amy from workers. So this is gonna. So it probably has something to do with, this is a set, and a set is immutable or something. Tuples can, oh, it's a tuple. Tuples cannot be modified. All right. Okay. All right. Anyway. Yeah, I get sets and tuples mixed up. All right. What's next? Additional practice. What time is it? 1:03. We are type conversions, binary numbers, string formatting. Let's keep moving here. Following program calculates an overall grade in a course based on 3 equally weighted exams. Okay, so we have this calculator reads in 3 grades, 1, 2, and 3, and then we add them up and divide it by 3, and then we print that out. Okay, so what are we supposed to do? These are entries in this grade, and this grade, and we run it, and it gets. So create a different version of the program that calculates the overall grade for 4 equally weighted programs. Each assignment is graded out of 50 points. Calculate the overall grade for 4 equally weighted programming assignments, where the assignments are graded out of 50 points, and assignments 3 and 4 are graded out of 75 points. All right. So what time is it? All right, so I'm just going to do one of these. Okay, so first of all, I'd like to point out that, again, I've probably pointed this out before, but this particular kind of interface here to debug programs is kind of problematic because down here you have to anticipate, or you have to know, which I guess in this case is not that bad, but you have to know what the order of requests are, you know, of input, you know, what the order of the input statements being executed is, and because you have to put them all in here before you can run this program, and so that means that you can never debug a program on here that has that where in your program, based on an input, there's a branch, or you know, there's an if then or something, and new input requests depend on a previous input request. Okay. You can't debug programs like that on this platform, but still, it's nice to have this pipe. And this, so they'll never ask you to do that, so don't worry about that. And by the way, Zybooks is working on a platform, an interface where you can do that. But anyway, but it is easier if we first see this, and then we type in this. And then we see this, and we type in this, and then we see this, then we type in this. Well, we can do that if we open up an editor. Let's see what I'm going to do is this. I'm going to go find my ITS128 folder, which is right here. And I'm going to go in there. And I'm just going to open up one of these called test 2. And I'm going to open that up in my, can I open it up in this one? Okay, so here it is. And I'm going to go back to here and copy this, copy, and go back to here and paste it here. So here's the program, and I'm going to, it's called test2.py, save it. And I'm going to open up my CMD, and this pops up, and I can go CD, OneDrive, I should do backslashes, desktop, backslash, ITS128, enter, and dir, here I am, it's this one. So I can do Python, python space test2, enter, and it asks me this question, and I answer it. $70, $75, $91. So I say 70, 75, 91. And my overall grade is this. What happens when I run this one? Okay, yeah, that's the answer. And I'll just do the first one here. Calculate the overall grade of 4 equally weighted programming assignments, where each assignment is graded out of 50 points. Okay, so it should look like this. One more. And by the way, I see no reason to put a new line here. Just don't see why we need that. Okay, this is exam 4. And we're supposed to, each assignment is graded out of 50 points. Okay, so I'm gonna, I gotta add plus copy, paste, paste, make this a 4. Ooh, I gotta make this a 4. And 1, 2, 3, 4, but I gotta do this, I'm gonna divide this by 4. And I'm gonna divide each one of these by 50. Just like it says right here. Okay, so divide that by 50. And this one, and this one, and this one. So now, once you divide it by 50, these are going to be percentages. And we're going to, and they all have equal weight. In this next one here, we got different weight, different points. Oh, yeah, they're all equal weight anyway. But so for the second one, we would make 3 and 4 be divided by 75. And I don't know what the third one is. But anyway, so let's save this and run it. And so I took out the line feeds there. So now it says, I type it in there and I can do, so this is out of 50. Now, so I got to make numbers smaller than 50. So I'm going to do 35. What's 75 divided by 2? Divided by 2 is 37.5. 91 divided by 2 is 45.5. And I don't know, 49. Your average overall grade is that. Oh, I bet I should multiply by 100. Times 100. How's that? Uh, 20, 30, 40, 50. Yeah, all right. Anyway, so that's that. Let's go to the next section. Type conversions. Okay, so sometime you're going to have to. Okay, so you should know about this. When you can mix types, and when you can't mix types, or sometimes you can mix types, and it just knows what you mean, and there wouldn't be any. There's no real ambiguity. Like here, this is an integer plus an integer, but this is an integer plus a floating point number. Well, it'll just treat this like a floating point. That's okay. This is 2 floating points, so it's going to return a floating point. So integer to float conversion is straightforward, but floating point to integer conversion would drop what's to the right of the decimal point. And implicit conversions between float and int, there's implicit ones and the ones you got to actually specify. Let's see. For any floating point answer, type the answer to the tenths. Okay. So I guess they're supposed to write the answer. So this is number of items plus number of items is 2 integers, so it's going to be 10, just 10. But item weight is a floating point number times number of items. So the answer is going to be a floating point number. 0.5 times 5 is 2.5, I think. All right, so and this is going to add 2 integers, but when you multiply it by a floating point number, it's going to return a floating point number, I think. So this is going to be 10 times 5 is 50. No, times 0.5 is 5. 5.0, I think. Yes, okay. Otherwise, if it's not implicit, if you really want a floating point number to convert to an integer, there's this int, or no, if you have something that can be converted to an integer because it's a number, or something that looks like it could be an integer, like a string string with just digits in it, that can look like an integer. Then you can do this int function where you put the thing you're talking about inside the parentheses, and then it's going to return, the integer version, that the number. Here's floating point, which goes in the other direction, which converts it into a floating point number. And this kind of thing is most often used with strings. In fact, it's most often used when you are asking the user for some input, and you're asking the user for input from the keyboard. The keyboard is only going to give you strings. And so if you're asking the user for a number, you're just going to get a character, a string of characters that are presumably all going to be digits with maybe a decimal point thrown in there. And then you want to manipulate that thing like a number, not like 5 characters, not like 3 characters. You want to manipulate it like one floating point number, for example. So you use this function. You use this function. And sometimes you have a number, and you want to go in the other direction, and you want to like you're printing out some stuff, and you want to include some numbers in the string that you're creating to print out. Well, you got to use this function to change the number, because you can use a plus sign, change the number into a string. All right. So this shows, this basically shows, exemplifies what I just said. So you can go through that. Enter a number, and that's what you enter, and then it's the original number. When you convert it to a floating point number, it's going to look like that. And when you convert it back, it's going to look like that. Yes, okay. Yeah. All right, so anyway, what is the result of each expression? This would be 1. This would be this. And this would be this. Okay, let's do this one. Let me see. This is chapter 3. We should really try to get through this. All right. Excuse me. You can do this. It's 116. I want to try to get through this. Okay, binary numbers is a completely different subject. Normally a programmer thinks in base 10, but we all kind of know what binary is. And we're learning this because we're gonna probably have to write some stuff to convert back and forth between binary and decimal. And so really this is, 212 in decimal. And really what it is it's 2 times 10 to the second power plus 1 times 10 to the first power plus 2 times 10 to the 0 power. Well, 10 to the 0 power, of course, is 1. 10 to the 1 power is 10. 10 to the 2 power is 100. 1,000, 10,000, 100,000, so on up. And this is how you compute. This is how this really breaks down to that value. And in binary, instead of doing 10 to a power, you're doing 2 to a power. Okay, so here the digits are 0 through 9, and then so you use 10 meaning 10. It's the next one up. There's 10 digits, 0 through 9, and so it's base 10. Here there are 2 digits, 0 and 1, and so you do 2 to the power. And of course, 2 to the 0 is 1, just like 10 to the 0 is 1. 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 16, 32, 64, 128, 256, 5, 12, 10, and so on up. And so that's that. And set each binary digit for the unsigned binary number below from 0 to 1 to obtain the decimal equivalents of 9, then 50, then 212, and 225. Okay, so first we want to do 9. So that's like 8 and 1. Okay. And then what? Do 50. 50 would be 32 plus 8. 8, not this. Oops. No. 32 plus 16 is 48. Plus 2 is 50. There we go. That's 50. 110010. 212 is going to be 128 and 64, and that's too high. Oh, 210, 212, 11010100. All right, that's kind of interesting. So convert this to a decimal number. Well, I guess you can use this to get this. Well, I know that that's 15. Yeah. This is well, anyway, so you can do this. Converting to create a binary number. Match the decimal number. It's supposed to do 3. Is it timing us or something? Is it timing me? 7. Dun, dun, dun. 5. 1, 1. Check. Oh, anyway. Okay, string formatting. Oh, yeah, you got to learn this. And this is, Python does it its own way. Maybe Perl is similar, but so this is a way to print out how to format. Okay, so you want to write something out like some number of burritos cost some amount, and so you want the sentence to look like this: some number of burritos cost this amount. And so what you do is you write your sentence here, just like how you'd want it. But where it's going to be, where you're going to put variables is right here. You put these little curly braces. It's like you're declaring little dictionaries or something. But no, that's not what you're doing. And then this whatever this variable was goes in the first one, and whatever this variable was goes in the second one. See, so that's how this works. And so you got to kind of remember this. Now this here, just that is an expression all onto itself. I mean, it's and so here you're just printing that expression. So, you know, you could do something like let's see, Python. Okay, I'm going to say number equals 6, amount equals 32, and then I'm going to say output sentence equals, and I can do quote, curly, burritos cost $, curly, end of quote, that, and then I do this decimal point format, and then I do number for the first one and amount for the second one. Okay, so that's that. Now that's what output sentence is. So now I'm going to print output sentence. I got to put a parentheses around it. Output sentence. Oops. And it prints it out. See, there you go. So anyway, so sort of remember this. And I tell myself that because this is something that's quite unique to Python, and you know, not like any of the other languages that I have jumbled around in my head. All right, so that's string formatting. So here's an example of that. You got 3 things, and these are just literals. They're just strings, and they're going to be popped in. Oh, there's an order. Okay, if you put these numbers in here, there's an order. So this hat's going to go in here. Yeah, hat's going to go in here, cat is going to go in here, and fat is going to go in here. See, so zero. This is the 0 index, which is hat. This is the 1 index, which is cat, and this is the 2 index, which is okay. So anyway, that's how that works. And here, this here, you're not using the indexes. Here, this is like a dictionary, isn't it? We are defining these things like that, using animal equals this string, headwear equals this string, shape equals this string. Then inside here, we don't put indexes, we put the key value pairs. All right, name replacement is what it's called. A keyword argument. Okay, so can't mix them up. Okay. I guess you can mix it up. This is okay. This is allowed. So you can mix them up if you're using keyword arguments, but not when you're using index arguments. Positional and name replacement in strings. Okay, so this reinforces that. So make sure you understand that. A lot more on this. Yeah, see, you can do this too. Instead of putting the quoted thing right here, you can define a variable with the quoted thing, and then you just put that here and then dot format. So what are we supposed to put for an answer here? April 22, 2020, enter April 23, 2020, 2024, enter. Yeah. All right. What happens if I didn't put the enter? Do I get it? Oh, now it's okay. All right, so anyway, indexing, you're going to print 9 both times, I guess. 9:9, I think. Yeah. I guess you're doing hi Bilbo. I think that's right. Double braces are converted to a single brace in the output. Okay, so it's this then. Double braces are converted to single braces in the output. Okay, this is today is April 22nd. All right, so a format specification is a replacement inside a format specification inside of a replacement field allows the values formatting in a string to be customized. Okay, so this is customization of this. This is gonna so this just says that you're outputting this as a string. This says you're outputting it, you want to output as a decimal number. This says you want to output it as a binary number. So here you're outputting the value 4 as a binary number. That's binary number for 4. This means you're outputting it as a hexadecimal number. And since it's a lowercase x, it's a lowercase hexadecimal number. So it's a lowercase 15 is F in hexadecimal. If this were a capital X, this would be a capital F. Here we're outputting in exponent notation. Here we're outputting in floating point notation. 6 places of precision is the default. If you want to change the default, you do that. This will put 3 zeros or leading zeros. This will put leading zeros. Precision, I see. Okay. Anyway, so that's pretty interesting. You may want to reference this someday. This one seems kind of maybe hard to remember. All right, let's see. So this makes sure you understand that. Referencing format. So referencing the correct format values in replacement fields. 3 is a string. This is a floating point number with 2 digits to the right of the decimal point. And this is also two floating point, 2 digits to the right. Here, okay, so this is just order, inferred order. This is where you're specifying the position. Yeah, this is the second, this is the 150, and this is the one in this position. And then here you're using name replacement. You know, you're naming these values. All right. All right, it's 1:30. I should probably, okay, so we are at the end of the chapter, but let me just do one of these, and one of these. Okay, string formatting. Let's just do it. Joe, is that? Hello, my name is Joe. My name is Joe. Yeah. Yeah, okay. Pretty straightforward. Printing a string. Write a string statement to print. Note that there is no space between the comma and the user number. I see. So print, okay, so you want to print this, right? A single statement to print. Print I don't know. dot format user word, comma, user number, close parentheses in the print. Oh, this should be a comma, not a period. All right, so that one, so that's that. And then, so what's the next one real quick? Okay, select the most appropriate replacement fields. Let me just start. Number of gifts equals 4. For Christmas, I got this. Well, yeah. Yeah, all right, what's next? Zeros, because it's that. Loan rate is 1, which is that. Okay, anyway, all right, so so I finished covering the chapter, and if anybody wants me to go over any of these labs, why don't you try them yourself, and if you have any trouble at all, post a question up in the raise your hand and ask forum, or you can post in the raise your hand forum. You know, I'm really having trouble with lab with .xx or whatever. Can you please cover it in a lecture, and I'll do that. Okay. Otherwise, I'll start on chapter 4 next time. You can always go back to it's also quite possible, of course, that the lab will be in the resources video list from last semester. Oh, I'm in the resources, and there's the video playlist from last semester. All right, are there any questions? See, wait a minute, let me look at that. Can you please, if you post these, okay, the only where I post these are in the playlist. So if you go to the, yes, so if you go back to here, you go to the syllabus, and right here, YouTube playlist, click right there, and the last video I made before today is right here. And when this recording is over, it takes about a half an hour, and I put it up there, and you'll see, you come here and it'll be video number 6. All right, so if there are no more questions, see you next week. Thanks for watching.